Hello everybody, I'm sorry I could not be in class today, but I hope this is a decent way to communicate the rest of chapter 16, section A with you. We're going to start out with example 4. Well, actually, I'm not even sure where we picked up that yesterday, so it might be another example, but I'm going to start with an example, let's just say. But it's in your textbook. It's on page 389. Excuse me. So the example starts with showing that the equation of the tangent line. So we're going to show that the equation of the tangent to y equals the natural log of x at the point where y equals -1 is y equals ex minus 2. So show that the equation, so this is going to be the equation of the tangent. We're trying to prove that the equation of the tangent is y equals ex minus 2 from the graph y equals ln x at the point where y equals -1 is this. So what we're going to do is we're just kind of going to get a rough sketch in a Cartesian plane. Here's x, here's y. And we have, let's say, the number 1 here and maybe -1 here, because I know they wanted y as -1, so I kind of wanted to isolate that. Anyways, at that point, let's make our little dot here because we know it goes through here, and then something about, how about like this? Let me try this a little bit straighter, and this is the asymptote down here. Okay, so this equation, this graph is y equals ln x, the natural log of x, and at y equals -1, so right here, we're going to have some sort of tangent, and that tangent has some sort of slope. Let's kind of make our line. And this equation of this line is the y equals ex minus 2. So now that we have that, kind of a picture of something drawn, excuse me for coughing, when y equals -1, what you are going to have is I'm going to substitute -1 into this. So I'm going to have the natural log of x equals -1, which is a no-brainer. And if we were to solve for x, to solve here, just to get x alone, you would have to take the e to both sides. So little e, and raise everything to the e power. So e to the ln is 1, so you're just left with x. And then on the right side, it'd be e to the -1st power, which is the same thing as 1 over e. So now this point of contact, we did all of that work just to find the x value when y was -1, is 1 over e. That's our point of contact. And the point of contact, once again, is the point where the tangent line hits the original equation. So now, at the function that we were looking at, the natural log of x, has the derivative of 1 over x, and we've known that already. The tangent at that derivative has a gradient. The gradient is basically going to be 1 over e, which is going just to be equal to e. If you wanted me to show you the math, it's 1 over 1 divided by 1 over e, and you can multiply by the reciprocal, e over 1. You can see how that cancels out. So basically, this is the gradient of the tangent, okay? And then the tangent equation, you would say y minus a -1 over x minus 1 over e, which would equal y plus 1 over x minus 1 over e. And that's going to be set equal to your tangent, your gradient, which is just e. to solve for y, this y right here, I'm going to multiply both sides by the denominator. So x minus 1 over e. So I'm going to have y plus 1 equals e times, actually I probably should have put a therefore y plus 1, let's get this zoomed in, why is it, okay, there we go, equals e times x minus 1 over e. And when you distribute to both terms and then subtract your 1, so I'm going to have y plus 1 equals e x minus 1. Then I'm going to subtract 1 minus 1. Y equals e to the ex minus 2. And that's what we originally were given, and that's how we had to prove it. Okay, so this is the first example on our new homework, our new notes for today. And today is the 21st, I believe. Maybe the 22nd, I'm not entirely sure. 22nd, today's Friday. Happy Friday, guys. Anyways, all right, moving on. Next example. Find the equation of the tangent to y equals tan x at the point where x equals pi over 4. Okay, so find the equation of the tangent. So now we're writing an equation at this point. To the y equals tan x at the point where x equals pi over 4. So you can do this a couple of ways. You can put just tangent to pi over 4 in your calculator and get the value out to find the point of contact, because so you'll know x equals pi over 4 and y equals, well, at pi over 4, the tangent, okay, so pi over 4 is 45. If we're going to draw a unit circle real quick, so this is a 45-degree angle, and at this point, you have square root of 2 over 2, comma square root of 2 over 2, and you know the tangent is y over x, or cosine, sine over cosine. So it's this over this, which is the same thing. So the tangent is going to be 1 at pi over 4, tangent to pi over 4. So the point of contact is pi over 4, comma 1. Okay, so now if f of x is tangent of x, we know that f prime of x is equal to 1 over cosine squared of x, which is all fine and dandy. To find the gradient of the tangent at the derivative, you're going to, and you know the point of contact is pi over 4, comma 1. You're going to plug in pi over 4 into cosine of x. And, excuse me, once you do that, actually we can use the unit circle. Pi over 4 is obviously 45 again. The cosine is going to be square root of 2 over 2. So you would have 1 over cosine, oh, no, take that away. Square root of 2 over 2 squared, because the cosine of pi over 4 is square root of 2 over 2. And then I'm going to square it because that's what it says right here, squared. So that's 1 over that. And you're going to set that equal to whatever this evaluates to. So let's see, how will this evaluate? Well, you would have 1 over root, so I'm just going to do some scratch work here, root 2 over 2 quantity squared. Well, this becomes just 2, and that becomes 4. So 2 over 4, which is 1/2. So 1 over 1/2 is the reciprocal of that, which is just 2. So it says, basically, that the gradient will be 2 at the derivative. So the tangent at the derivative is 2. So now to find the equation of the tangent, we're going to say y minus 1 over x minus pi over 4. And that's going to equal 2 because we already knew that. And we're going to go through and solve for y. So I'm going to again multiply by the denominator. Y minus 1 equals 2 times x minus pi over 4. I can go through and simplify this. I'm going to have y minus 1 equals 2x minus, now 2 pi over 4 is the same thing as pi over 2. And then I'm going to, I'm going to take this and add 1 to this, but I'm not actually going to add the 1 to this. So I'll show you how, when I'm not going to put the 1 inside there. I'm not going to combine the like terms. So it's going to be y equals 2x minus pi over 2 plus 1. So it's going to look like that. Okay. We have 2 more examples. This next one is basically a calculator example. And we're going to be looking for the point where the tangent meets the curve. So find the coordinates of the points. So I'm giving you kind of like one of each point or points. Let's just put point or points. I'm giving you one of each. In fact, we found in the first example, we found an equation. Well, we proved the equation. The second example, we were asked to find the equation. This example, we're trying to find that point, that actual like point of contact. So find the coordinates of the points where the tangent to y equals x to the third plus x plus 2 at 1, 4 meets the curve again. Okay, so in order to do that, we're going to say, f of x equals x cubed plus x plus 2. We have to take our derivative, because that's how we're going to find the tangent line, equals 3x squared plus 1. And now we know that we're plugging in 1 into this. So we're trying to find the points at which the tangent, so we have our tangent line, our derivative at least, and we're going to plug in 1 to the derivative. So we're going to say f prime of 1 is 3 times 1 squared plus 1, which is the same thing as saying 3 times 1, which is 1. I'm sorry, 3 plus 1 is 4. So we already knew that 1, 4 was our point. So what we can do is take that point and say 4x minus y equals 4 times 1 minus 4. Okay. And then we can say basically by solving for y, oops, that's not what I meant to write, 4x minus y equals 0. By solving for y, I'm going to add y over each side. Y equals 4x. Okay, so now what you're going to do is you're going to put this original equation in your calculator. You're also going to put this equation in your calculator, okay? And you will see once you graph it, and I'm going to show you on the computer screen. Once you graph it, so let's do the TI Nspire here, or the 84. There we go. So you have your graph. This is the curvy graph. This is the curvy graph. And then you have your 4x going down. We already know 1, 4 is going to be our first point of contact, but it also meets down here. So you're going to have to get both points. So this one is the one they gave you. This is the other one that they're going to try to figure out. And that comes out to be, by using a graphing tool, -2, -8. Okay? All right. Last problem for the day. Okay, it says, this is the last example. find the equations and by the way, I know this is hopefully without being said that you guys can stop and fast forward or rewind or pause whenever you need to. I know I should have said that earlier, but I felt like that's kind of already known. Find the equations of the tangent to y equals x squared from the external point to 3. Okay. So find the equations of the tangents to y equals x squared from the external point 2, 3. Okay. So what this looks like if I'm going to graph this, just a quick little, cute little sketch. Well, x squared, you know, goes through 0, 0, 1, 1, 1, 2, 4, something like this. Cute little sketch. And there's some sort of external point, 2, 3, 1, 2, 3. So like maybe right here. So this is the external point, 2, 3. And we're trying to find where it has this point of contact. And the point of contact when we draw a tangent is going to be some value, I don't know, a comma a squared. We don't know what that is yet. That's that general point that when you have a tangent that's going through this external point that's not on the curve, that it's going to extend to hit the graph at one section. We're just going to have a comma a squared because a squared is x squared. All right, so now f of x equals x squared, f prime of x equals 2x. Okay. So basically, if you're going to put in, if we said a, so basically f prime of a is 2a. So if we're going to find the equation at the point a comma a squared, we would say y minus a squared over x minus a. And you know that the slope is going to be equal to this derivative. So we're going to say 2a instead of 2x to make sure it's all in terms of a. Okay, so now I'm going to do the same thing that I've been doing. And that is multiplying by the denominator. So I'm going to have y minus a squared equals 2a times x minus a. I'll distribute, so I'll have 2ax minus 2a squared. And then I'll add that a squared over. So my final answer, let me see, it's getting a little low here, so is 2ax equals, adding the positive over, not 2ax equals, 2ax minus a squared. So that is the equation for the tangent at the point a comma a squared. So that's this line, that's this equation right there. Now this tangent is going to be passing through 2 comma 3. Okay, so what we're going to do is we're plugging 2 and 3 in for x and y. So I'm just going to do this work over here. So 3 equals 2a x, right? Was it 2ax? Yep, and x was 2. 2a times 2 minus a squared. Okay, so in that case, I'm going to have, let's see, 3 equals 4a minus a squared. And look, we're building a quadratic equation. Let's get everything over to the left-hand side, so this equal to 0. So 0 equals a squared minus 4a plus 3. And we can factor that very easily because what are factors of 3 that add up to -4? And that'll be -1 and -3. So I'll have a minus 1 times a minus 3 equals 0. So a is going to be equal to either 1 or 3. So now there are exactly 2 points, because you're going to have either one of these, that pass through the external point 2 and 3. With a equals 1, the point of contact, you're going to go back to the tangent equation, which our tangent equation was Well, we actually haven't made that tangent equation, right? Have we? Don't know if we did or not. At a equals 1, the tangent equation would be y equals 2x minus 1. And then with a equaling 3, our other equation would be 6x minus 9. And if you need help coming up with these tangent equations, I can show you, but it's pretty simple to do. So the other points would be, the point of contact would be 1, 1, and this would be 3, 9. Because you're putting the 1 here and then the 3 there. All right, this ends our talk for today. We give you your homework. All right, so your homework is going to start on page 389, number, let's do 8, 9, 10, C only, 11 through 13, all, and 14 through 18. Okay. Have a great weekend, and I'll talk to you soon. Bye.